What's up people, this is Vishal and I'm back again with another video. In this one we'll be talking about memoization, but before we get into the video, about 65% of you have not subscribed to the channel, and if you have not subscribed to the channel, please subscribe to let me know that you like my content, and that gives me motivation to bring in more good stuff for you guys. So without wasting any further time, let's get into the video. So let's first understand what memoization is. So memoization is a technique of remembering the result of an expensive operation. So let's say there is an expensive job that takes an input of A and B, and whatever the result that is computed out of those inputs is stored in the memory against whatever the input that was provided. So the reason why we do that, so whenever the same expensive job is asked to run for the same set of inputs, we would just return the data from the memory instead of recomputing the entire expensive job that we were talking about. Okay, so let's quickly take a look at the simple function that I've written over here. So I've created a function over here called memoize, which is a closure. Okay, so it is initializing a constant over here called cache, in which, so cache is the constant in which I'll be storing the data that I'm computing. So it is returning another function which takes an input of function and the arguments as an array. Okay, so whenever I call this function, it is going to generate a hash key based on the arguments that is passed to the function. So this generate hash key function is very simple. It is just concatenating all the arguments with the help of a pipe. Okay, so this is what it does, and whenever the key is generated, we just check whether the key is present or not, because we have a default value of an empty array over here. So we just check whether the key is present or not. If the key is present and the cache has own property, so we are using cache dot has own property. So if the key is not present in cache, that time we just compute the function. Okay, we call the function that was passed, we apply all our arguments, but we basically compute that particular expensive job and store the result in the cache, and then we return the data. So now whenever the same call is invoked again, so again the same arguments are there. So let's say a comma b hold the value of 1 and 2. So if when the function is again called with 1 and 2, it will again generate the same key, and since this cache will have the key present in its memory now, it won't go inside the if condition, it will directly return from here. So we are basically not computing the expensive job again, we are just referring to the memory and returning the data from there. So of course this use case is very specific to the situations when the function that we are passing over here is always going to return same result for same set of inputs. Okay, so for a quick implementation of this, so let's create a const memoize equal to memoize. So what we are basically doing over here is we are calling this function to initialize our cache. Okay, the reason why I'm using a closure over here is because we don't want any external elements to touch my cache. Only the memoize function and the things that are there inside the memoize function will have access to the cache. Hence we are using a closure for that case. So when I call memoize function, basically whatever the function that is getting returned is it will be assigned to this memoize constant, right? So let's create a simple function over here called const multiplier equal to, it's a function, it is gonna take two arguments, which is a comma b. So let's add that. Okay, of course this is not an expensive job, but for an example you can just think that this is a very expensive job and it is taking two inputs and returning one output, right? So let's say I want to memoize the multiplier. So what will I do is, I know that this memoize constant is now storing the definition of this particular function. So what we'll do is const result equal to, we will call this memoize function. We know that the first argument is going to be function. Okay, so we will pass multiplier over here, and all my arguments will be going as an array. So we will be passing 2, 3. So let's say I want to compute the result for 2, 3. So this 2, 3 will be taking the place of the arguments. We will generate a hash key out of it, which will basically look like 2 pipe pipe 3. So the hash key will look something like this, and that particular key is initially not there in the cache, so we will then use function dot apply. So the people who don't know what dot apply is, you can check out my video about bind, call and apply. You'll get the idea from there. So once we do function dot apply, we pass all our arguments. So apply takes the arguments in an array, right? So we already have an array, so we'll just pass in those arguments. Whatever the result that is computed will be stored inside the cache using the key that is 2 double pipe 3. I'm sorry, there will be no space. So 2 double pipe 3 is the key, and whatever the result is, that is 2 into 3 is 6, and that particular information will be stored inside my cache. Now whenever the same function is called again for 2 comma 3, so it will again go inside this, it will generate the same key, 2 double pipe of 3. Now the cache will have this particular key stored, so we will skip this if condition and we would directly return the cache of key. So it basically is not computing 2 into 3 anymore, it is directly reading from the memory and presenting it to the user, right? So this is what memoization is all about. But the purpose of this video is not to understand this synchronous memoization. We will be talking about asynchronous memoization. So we will be writing a very similar memoize function for remembering the result of an asynchronous operation rather than a synchronous job that this particular function is doing. So before we start writing our utility to memoize asynchronous operation, let's try to understand the setup over here to basically demonstrate what the problem is and how by using the memoization utility we'll be solving that problem. Okay, so let's start by looking at my Express server. So on my Express.js application, I have a very simple API over here, which is /greet/name. Okay, so name is a route parameter, and which basically executes greet person function. And in this function, I have placed a set timeout of 4000 milliseconds to basically mimic an expensive operation. And what this function basically does is you just pass, you just call the API with /greet/Vishal, and it will basically return hello Vishal. And similarly, whatever the name you pass, it will just going to return hello so and so name. Okay, so just to mimic the expensive job, I've placed a 4000 milliseconds set timeout over here. Okay, that's all I'm doing in my Express.js application. Now in my React application, I have two components over here. One is playground and the other is problems. So name of these components doesn't matter, just understand what is there in the use effect. So inside my use effect, I'm basically making a fetch call to the API, which is /greet/Vishal, and whatever the data that I'm getting, I'm using the set message to basically set the data in the message. So whatever the response that I get from the server, it is going to be stored inside the message state over here, which I am basically accessing and displaying on the screen. So this is what is happening on both the components. One is the playground, where the API call is /greet/Vishal, and one is the problem, where the API is /greet/Neeraj. Okay, so let's head on to the browser and see what the problem is, right? So this is my React application that is running. I'm on the network tab already. So let's go to the playground, and you can see there is an API call going, and after 4 seconds it responds and I get the hello Vishal message printed on the screen. Then I go to the problems component, then a new API call goes, and whenever after 4 seconds, whenever it succeeds, we show hello Neeraj printed over here. Right now the problem is this, for these particular APIs, for /greet/Vishal, /greet/Neeraj, I know what the response is going to be always. So no matter how many times I call this API, it is always going to return hello Vishal. No matter how many times I call this API, it is always going to return hello Neeraj. So now the problem is, now when I go back to playground, again the API call goes. I know that this particular API is always going to return hello Vishal, and this particular API is always going to return hello Neeraj. Still we are, whenever I'm switching between the components, we are still making an API call, and it is again taking 4 seconds, and when I go back again takes 4 seconds, when I go back again takes 4 seconds, which is the problem for these kind of APIs, which I know that what the response is going to be, or whatever the input that I'm passing, I know what kind of response I'm going to get. I would like to memorize this particular response. So what happens in that case is basically I call it once, and for this next subsequent calls, all these calls will be avoided from the browser, and instead of making a call to the server, we would directly read it from the cached data. Okay, so this is the problem that we are trying to solve. Let's jump into writing our utility. So I've already created a file called memoize.async.js. So I'm not going to show you the directory structure. Just understand that everything is linked and it is going to work fine. If you want a video to understand the my project structure, just let me know in the comments, and I'll make a video on how I've set up my particular project structure. Okay. Now, so coming back to the video, I have already created a memoize async function over here. So we know what the problem is. We know that we are basically going on making multiple calls, though we know what the response is going to be. And since this is an expensive call, it is always taking 4 seconds and making the user wait for 4 seconds on a blank screen, right? So this is what the experience, this is the experience which I want to fix, and I want to fix it by using my memoization async utility. So first things first, we need some space where we can store the data, right? So we'll again create a const cache, okay, which is going to be an empty object, and again this is going to be a closure. So the reason for having a closure over here is pretty straightforward. I told you already that we don't want any external elements to basically modify or access my cache. I want only the things that are there inside the memoize async function to have access to the cache. So that's why we are using a closure over here. Now what is the definition of this particular inner function? So let's say I want to take a config, okay, and I want to take a callback as well, okay. So whenever the asynchronous job has completed, what function it has to execute. So that particular callback I'm going to take. So now what do we do next? So I want my config to have several details. So let's read those details into the specific constants. So I want a URL, so to which I want to make requests to. I want duration, okay. So for how long I want to cache this information, okay. So this duration, we'll be using this later in the video, but let's understand that this config is going to take this information as well. And the third thing is, it is going to take a key. So against what key I want to store this particular data. So all this configuration is going to be supplied by the implementer of this particular function, and we will see the implementation as well as we go on, but let's understand that this config is going to have a URL, a key, and a duration. Right now, what next? So first things first, if the cache dot has own property of whatever the key is. So if cache already has the data, just return cache of key, right? So this is what I want to do here, okay. Next is, if it doesn't have the data, we are gonna use our fetch and make a call to the URL, okay. So whatever the key is, I already have the key information with me. We'll use that inside our .then function, but using the fetch, we are making a call to the URL. Now .then, inside my .then, again the first things first, we want to get a JSON out of it. So let's instead of data, let's call it response, okay. Sorry about that. All right, so we are going to call it response and write response.json, and inside my next .then, now this is the place where I want to store the data inside my cache. So let's do that quickly. So we have our data here. Now at my cache of key, I will basically assign the data, okay. So along with the data, I would probably want to use along with the data, let's store the duration also. So how long this data has to sustain in the memory. So instead of assigning the data directly, I'll just create a data key over here and a duration key over here, right? So instead of returning cache of key, which is now having a data and duration, let's just return cache of key of data. So this is basically only going to return the data that is present in the memory, okay. So once we made an API call, we got the response, we stored the data inside, everything is fine over here, and we know that we have a callback. So instead of returning this particular thing, we would want to use our callback. So we will write callback of cache of data. Okay, so this is what I want to do, and let's just skip the return as well. So if the data is already present, we already know what callback has to what definition the callback is holding. We will just call the callback. Okay, the same thing we want to do over here as well. So we have all the data. We will use callback of cache of key dot data. Okay, so this is a very simple implementation. Let's try to see if it is solving all our problems, and then we will build on top of it. Okay, so I have already created this information over here. Let's go to our components now. And inside my component, let me just re-verify this. Cache has the data. If it doesn't, and we would like to return from here. Okay, now let's try to verify this by implementing this memoize async into our components and see if it is actually solving our problem. If it doesn't, we will try to fix it back. Okay, now we go into our playground.tsx and let's see how we'll implement this. So inside here, we will write import from at commons commons utils, and use my memoize async function over here. This is the first thing. Since I'm using TypeScript, I'll also import the types of the configuration. So I've already created a type of the configuration, so let's do that as well. So inside my commons types, we will take memoize async, right? So this is a interface that is basically defining the config, right? So we need a key, we need a URL and a duration, right? So this is basically defining that. So this is what I want. Apart from that, I think I don't want anything else. So let's just try to implement this. So instead of directly calling the fetch over here, now I will call my memoize async. Okay, so now we know that memoize async needs a config and a callback. So let's define our config over here, const config. This is going to be of type memoize async, and it will need a URL. So URL we already know, we have already defined our endpoint over here. Now we need to generate a key. So for generating the key, I'll again use my generate hash key function. So in the first half of the video, you already saw what the generate hash key is. So we will just simply import that from at code along utilities generate hash key. Okay, so let's use this to get our hash key. So generate hash key, and what do we need over here? So we need all our arguments in an array. So I know that I'm making a get call, so I'm going to make a hard-coded get information over here. You can use it whatever way you want, but for the purpose of this video, I'm hard-coding the get method over here, and I'll just create my key based on what method I'm using and what is the endpoint. Okay, and I want to cache this information for 20 seconds, so we will write 20,000 over here. Okay, now inside my memoize, I'll just pass my config. Okay, and we need a callback as well. So let's write our callback over here, which is gonna do set message, and the callback is already going to receive the data, right? So whatever the data that is cached is gonna be received by the callback. So let's just use that data over here. Okay. Okay, so I think this data has to be of a type. So let's define a message over here, right? So yeah, so whatever the data we got, we are now using the set message to basically update that data. Now the same things that we did over here has to be updated inside my other component, that is problems.tsx. So let's just copy the entire use effect method and go to our problems, and just replace this with this. Okay, so everything is going to be same because the only difference that is going to happen is with the endpoint. So I can blindly copy this part. Now let's just move all my imports over here. Okay, so everything is in place. Now let's see if our build is succeeding or not. So build is succeeding. Let me run yarn run build again. Alright, so everything looks fine now. So let's go back to our component, hit a hard refresh, and now let's go to playground. So we got the data over here. Okay, now we go to problems. We made another API call to /greet/Neeraj. Now I go back here, everything looks fine, right? So now we are not making another API call. The reason why we are not making another API call is because from here we already handled that case. So where this is the first time we made a call. We updated the cache with the key and whatever the duration and data that we wanted, and we executed our callback over here. And for the next calls, of course, when I'm switching the components, the use effect is again calling the memoization function, but this time this cache is already holding the value of get whatever the key is, right? So let's just update our memoize async function again with a console log. So we'll write console.log reading data from cache for key and whatever the key that I want over here. So let's just write $key. Okay, so this is just for our information that we are reading something from the cache. So let's go and build our utility again, and once it is built, it automatically updates my component. So now let's look at our console. So first API call went for greet/Vishal. Now we go to problems. The next API call went for /greet/Neeraj once the data is back. Now go to our console, go back to playground. You can see that we are now reading both of this information from cache, right? So we are not basically making another API call. We are reading the information from cache, and notice what key is over here. So whatever the arguments that I passed to the generate hash key function. So the arguments that I passed was the endpoint and get over here. You might want to create a different kind of key based on your use case, whatever you like, but the core of the problem is going to still be the same, that you have a specific key alongside which you are storing the specific data, right? So this is all getting read from the cache right now. Now let's try to see one of the problems with the current implementation. Let's go back to our playground, hit a hard refresh, and while the API call for greet/Vishal is going, I'll try to switch between the components. I'll basically cycle between the two components. We will basically see multiple API calls going in, right? So we switch between the components. You can see while the API call is waiting for the response for the first one, the user basically switched between the multiple components, and you could see there were several calls made, and each of those calls are basically waiting for 4 seconds, 4 seconds, 4 seconds, and so on, right? So this is basically increasing the stress on my server for no reason, right? So it is something which is going to increase the stress on my server. So let's try to solve this problem as well. And to solve this problem, we will do another thing. So we will create another constant over here, which we will call in progress queue. Okay, so in progress queue is basically going to hold the information of what data is already being fetched from the server. If it is already being fetched, no need to make the fetch call again. This is what this particular in progress queue is going to hold the information about. Okay, so let's go to our code again in the function. I would want to use the in progress queue. So we will see that in progress queue dot has own property of key. So let's do it in this way. If it does not have any property, so we will first say that, okay, right now there is no API call actually going on. So we will update our in progress queue with that particular information that something is going on, right? So in progress queue dot in progress queue of key equal to an array of callback. Okay, so the reason why I'm using an array of callback over here is because let's say the user is switching between multiple components and there are multiple API calls trying to go, and for each API call there is a callback. Now what I'm basically doing is I'm just registering the callback inside an array, the sequence of all the callbacks, and instead of making the API call, I'm just storing the callback so that whenever the first API has responded, we will execute all the callbacks by using a for loop. So we will be updating our code for that, but just understand why we are using the array of callbacks over here. So let's say I made 3 API calls and 3 API calls had 3 callbacks. So instead of making 3 API calls, I will make only 1 API call and execute all the 3 callbacks, because I know what data is gonna be coming from that particular API. Okay, so in progress queue dot has own property of key. If it doesn't have, we are basically assigning something over here. Else if it has, that time we are just gonna do in progress queue of key dot push whatever the callback is. Okay, so when the in progress queue was empty, we created an array with 1 callback, and for every subsequent calls that are coming for the same particular function, we are basically queuing all the callbacks. And one more thing that we want to do right now is, if it is already present, we are going to return from here. Okay, so if the in progress queue of key has the data, we are basically saying that push the callback and return from here, so that you don't have to make another API call. Okay, so this looks fine. Now we will have to also update this area where we are directly calling the callback function right now. What we will do over here is we will say we will basically use our for of loop. So that is going to be let CB, so of in progress queue of key. Okay, so for all the callbacks, whatever the callbacks that have queued, so whenever the first response has come, by that time, let's say 3 more requests have come to the same utility, we are updating our in progress queue with all the callbacks. Now all those callbacks that have queued, we have to, whenever the data is back, we have to execute all of them. So what we are going to do is let CB of in progress queue of key. Now what we will do, we will basically execute the callback and pass in our information, that is cache of key dot data, right? Okay, so this basically I think will solve and this problem that we just saw. So let's just build our utility again. So let's go back to our browser and let's go to the playground, hit a hard refresh, and you can see that the first API call is going. Okay, now I think we wanted to test something else, right? So let's hit a hard refresh again and switch between the components, and you can see that there are no subsequent API calls going, right? So we so though the user was switching between the components, now the memoize async utility that we have written over here is taking care of not triggering the API call again and again. Rather, it will just queue the callbacks, and once the callback is queued, we are basically just looping over all the callbacks and executing each of them, which obviously are going to do the same thing. Now let's look at the console to see if there are any errors. So there is a warning over here that says can't perform React state update on an unmounted component. So this is a very simple thing to solve. We will try to solve that in our component over here. So whenever my component is mounted, we will just create a const over here is mounted equal to true, right? And before we do the set message, we will just check is mounted. Oops, this has to be mounted. Okay, if it is mounted, only then we trigger the set message function. else we won't be triggering that information. And when this particular component is getting unmounted, so for unmount we just need to return a function over here, and here we will write underscore is mounted equal to false. Okay, so of course this is a const, so let's change this to let. All right, so this should basically solve my problem. So let's go to our problems as well. Now if we go back to our website, hit a hard refresh, you will see that the API call for greet/Neeraj is going on, and we go to the playground, again switch back to problems, again playground and problems and playground and problems, and you can see that there were only 2 calls made instead of making multiple calls that were happening before. Now inside the console also there are no errors on the state update, that we are going to update the state on an unmounted component, so that we have already taken care of. So this is also fine, and everything is getting read from the cache right now. Now the one final thing that I want to do over here, so remember in our memoize async we were passing a duration, so we were storing the duration, but we are currently not using that duration anywhere. Also one more thing that I forgot to do is once there are the in progress queue is getting triggered, so all the callback functions are getting triggered. After that we need to clear the in progress queue, right? So we have already catered everything that was there in the in progress queue over here, so we need to clean up this thing. So how do we clean up? We will just delete the key that was there inside our in progress queue. So in progress queue, and whatever the key was, we are going to delete that key. So this is specifically for cleanup. Okay, so for cleanup we basically just delete the key from the in progress queue, but the cache information is already is still there inside the cache, so this would still work fine. We do a hard refresh, switch between the components as much as we want, the number of API calls are still going to be 2, and the data is always going to be fetched from the cache. Okay, now one more thing, the last and final thing that we want to do is with the duration. Now we are in our playground.tsx, we have written that I want to cache this information only for 2000 milliseconds, 20,000 milliseconds, that is 20 seconds. So after 20 seconds we should basically clear the cache, and after 20 seconds if we switch between the components, it should again make an API call. So how do we do that? It is going to be another simple thing. So we will use a set timeout over here, and the set timeout is going to do a very simple thing. So it will wait for the duration that we want. So the duration is 20 seconds, so for that 20 seconds we will put a set timeout of 20 seconds. So as soon as the call stack reaches this point, it hands over the control to the web API, and after 20 seconds we trigger this particular function. So what do we want to do in this particular function? Very simple, we'll just delete the key from the cache. Okay, so we delete the cache of key, and we also delete the in progress queue of key. Oops. So this basically makes sure that after 20 seconds my cache is empty and there is no information for whatever the key that this is going to execute for. And we would also add a console.info over here which says clearing cache for key, and we will write $of_key over here. Okay, we will build our utility again. So once this is built, I go back to my website, and you can see that the API call has went for this. We go for Vishal, we come back, there is no second API call being made, right? So we have handled that scenario well. Now we are reading the data from cache, so on, and after 20 seconds it will basically clear the cache on its own. So let's see. So after 20 seconds you can see clearing cache for key, whatever the key that was there for Neeraj has been cleared. Now after 20 seconds for /greet/Vishal, even that key is also cleared. Now This means if the cache is cleared and I go back to my problems component, there should be an API call for /Neeraj. So let's go here. You can see there is an API call for Neeraj. Now I go back here, you will see there is an API call for Vishal, because both of this information has been cleared from cache. And now we switch back and forth between these two, and you can see the data is now again getting fetched from the cache, right? And after 20 seconds again, it will clear the cache. So this is a very important utility, and it will be very useful for the use cases where you are let's say making a dashboard and you make multiple API calls, and you don't really want the those heavy operations that are getting in the data for an year or 2 years and so on to basically get triggered so frequently, because it is going to increase the load on the server as well, and on the user experience you would go on showing a loader for, let's say for this scenario we had a call for 4 seconds, so in the real-time scenario it might be more than that as well. So to avoid those kind of things, we would want to use the memoization async utility, and this will make sure that once the data is with you, for let's say for my use case I wrote 20 seconds, maybe you can cache it for 5 minutes, and for 5 minutes but the user will not see any updates on the website. Only after 5 minutes, when the user comes back, they will see a new API call going and fetching the data and basically update the website. So that's a lot of information, but that is all for this one, guys. I hope this video was very useful for you guys, and I hope you learned something new. So like and share this video and subscribe to my channel for more such amazing concepts in the future, and hit the notification bell to get notified about my videos whenever I upload them. So see you in the next one. Bye.